Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And we're starting a new course, and this is a pre-calculus course. We already have 3rd grade, 5th grade, 6th grade. What else we have? Algebra 1, Algebra 2, which will be 8th through 10th grade. We have Calculus 1, Calculus 2 for college. But we didn't have a pre-calculus class, so there's a local need for that. So hey, here we go. So let's get after it. This first session will be getting a few formulas out of the way, and then we'll jump into next session with circles. Eventually gets to parabolas, ellipse, things of that nature, conic sections. But tonight we're going to look at the distance formula and the midpoint formulas. So let's jump in here. Okay, we have, imagine if you will, these are straight lines, okay? It looks, now that I look at it, it looks a little downhill, but you get the point. Okay. We have a line that's drawn from the points X and Y, 1, 2. So the first, in a set of parentheses like that, the X coordinate is always listed first, and then the Y. So 1 value of X, 2 value of Y puts us at that point. You'll see the point over there, it's 7, 6. So X is 7, Y is 6. So there's a line drawn between the two. So the question is, there's two questions here. One is, what's the length of that line? Second question is, what's the midpoint of that line? Okay, let's answer the first question first. What's the length of that line? Okay, if I have a triangle, we've all learned A, B, C, that A squared plus B squared equals C squared. Okay, if I want to know just C, the length of that line, I just take the square root of A squared plus B squared. And that equals C. That's exactly what we have here. We're sitting there looking at that point which is 7, 6. This point which is 1, 2. Okay. Now you'll notice the coordinates are over here like this. So if I'm looking at the length of this line, it's this total length minus that length. That would give me the remaining, this distance right here. Okay? It's the same here. So if we want to know the length of that line, we would take the 7 minus the 1. X is 7 minus the 1 would give me a length of 6. B, or the vertical side's the same. So here's the, let me get that out of the way. You'll see that we're not at 0, we're up 2 units. And then this is up 6 total from that axis. So again, it's this full length is 6 minus the 2 gives me this height of 4. So then when you're looking at this side, then you're looking at x sub 2 minus x sub 1 squared. That's a squared plus the b squared, which would be y sub 2 minus y sub 1. That's squared. And the square root of that sum, that would be my distance, or the length of that line. So in our case, what does that look like? We had 7 minus 1, so the square root of all that, 7 minus 1 squared plus y sub 2, which was 6 minus 2, 6 minus 2 squared. So I have the square root, 7 minus 1 is 6, 6 squared, plus 6 minus 2 is 4, and that's squared. So let's get up here where we can see what's going on. We've got the square root of 36 plus 16. Square root of 36 plus 16, that's the square root of 52. All right, 52, what does that look like here? 52, 2, going to that 28 times, 28, 28, 52, no, that's 6, sorry. 52 divided by 2, 2, 4, 12, 26, sorry. 26. Okay, 2, going to that 13 times, 13, 1, 1. So now the factors of 52 are 4 times 13. Okay, so what does that mean? I've got the square root of 4 times 13, and you know the square root rules. You've got a times b and the square root of that. That can be taken as the square root of a times square root of b. Okay, so in our case we have square root of 4 times square root of 13. So I end up with 2, square root of 4 is 2, 2 square root of 13 is the length of that side right here. And that looks really sloppy, doesn't it? All right, 2 square root of 13. What about the midpoint of that line? Well, there's another little formula. If I'm looking at the x term, so I'm looking at 7, I'm out here at 7. So 7 plus 1 divided by 2. So x, the midpoint of x is x sub 2 plus x sub 1 over 2. So in our case we had a x sub 2 was 7 plus x sub 1, which was 1, divided by 2, so that's 8 over 2, and that equals 4. Now when we get an x and a y midpoint, those will be coordinates. Okay, so y sub m is y sub 2 plus y sub 1 over 2, and that equals y sub 2 was 6. So you see the y sub 2, y sub 1. Okay, 6 plus 2 over 2, oh, that's 8 over 2. That's going to equal 4 also. So the midpoint then would be 4, 4. What does that look like here? 4, 4, somewhere about right there. Is that about right here? Not bad. Okay. Not bad graphics there. Okay. That would be how you would use the distance formula and midpoint formula on that to figure out the length of that line and its center point, center coordinate. You might be asking yourself, well, what if I had a point down here somewhere and had a line that went on the negative side? All right, what if I had, let's get out here at -4, -3, somewhere about right there. Okay, so I'm going to try to draw a line right through there. Okay, assume that's a straight line. Okay, I need to come up with a ruler or something. All right, so this point over here was 4, 1. And this point is -4, -3. Okay, our distance minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and the square root of that sum. So what do I have? x sub 2, we'll just call it 4. Get my square root sign here. 4 minus something plus, well, and that something, the reason I put it like this, don't let that negative throw you off. It goes right there. Sometimes that's where the algebraic mistakes. Oh, 4 minus 4. It's not 4 minus 4. It's 4 minus a negative 4. Okay? All right. Plus y sub 2, which was 1. 1 minus something squared. And that something is a negative 3. Now you know the rules. If you haven't, if you don't, look at the algebraic rules video. 4 minus a negative is plus a positive, so that's 8. 8 squared plus 1 minus a negative is plus a positive, that's 4 squared. Okay, so now I've got 64 plus 16, and what is that? Square root of 80. Well, 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 5 is 1. So I've got 2 times 2 is 4. 2 times 2 is 4. Times 4 times 4 is 16. So 16 times 5. 16 times 5, which is square root of 16 times square root of 5. All that equals 4 square root of 5. That would be the length of that line. 4 square root of 5. Okay? And that's a sad looking square root sign, but you get the idea. Okay? Now, what's the midpoint of that one? I'm going to leave that formula up there for the distance. Okay, the midpoint. So x sub m, that was x sub 2 plus x sub 1 over 2. Okay, x sub 2 was 4 plus a negative 4 over 2. Well, what's 4 plus a negative 4? 0. 0 over 2 equals 0. Okay, so x sub m equals 0. Y sub m equals y sub 2 plus y sub 1 over 2. All right, y sub 2, 1 plus a negative 3 over 2 plus a negative, so what does that give me? A negative 2 over 2, which is negative 1. So y sub m is negative 1. So my coordinates for the midpoint then would be 0, negative 1. Okay, 0, negative 1. Well, that's that point right there. It's a wonder my line went through that. Okay. All right. So is that about the midpoint? I can't stretch it out, but yes, this looks somewhat in the middle. Okay. These are just simple examples of how to use the distance formula to calculate that distance from one set of points to another, and then find the midpoint. Now, finding the midpoint becomes critical sometimes because eventually we'll get into circles, and it's good to know how to find the middle of something, especially if this were a circle and that was representing a diameter. How would you find the center of the circle? Then you could use the midpoint formula to find the center of that circle, then the resulting radius, and know the coordinates of that center. Okay? All right. This was an example of pre-calculus, distance, and midpoint. Why are we doing this? Hey, we're trying to build a better tomorrow and do that together through math, okay? and more to come. So we're just trying to kick this off and get it going. Soon we'll be into circles and we'll work through those. So anyway, that's all for now. Hopefully you enjoy it. And if there's any comments, I should say this. It's been brought to, I live in the Philippines now, and there's several classes around where, and I don't know why this is, but the classrooms don't have books. If you live somewhere and you have students near you that don't have textbooks in their classroom, help them out, okay? Try to get them some textbooks, get them some other than just PowerPoint slides that they have to go print. And I don't know, I have books everywhere that I use and have for years as references to maintain knowledge. I cannot imagine not having a book. So buy a book, pass it along to somebody, okay? Let's do that. Why? That way together we can build a better tomorrow. And do that through math, or do that through other knowledge. Doesn't have to be math, okay? That's just the subject. I enjoy that in engineering. But spread the knowledge, okay? Buy a book for a student. All right, that's all for now, and we'll talk to you next time. Thanks.